Jason Griffey, who is a pretty remarkable guy, and I am super excited because he's going to be giving us new material tonight. So Jason's a dude who goes out and is on the speaking circuit quite a bit. He's done a lot of amazing things. I'm sure you're going to hear about some of those amazing things he's already done, but he's talking about some new stuff, which is great. So Jason is a fellow at the Berkman Center for Internet and Society at Harvard. He has won a couple of grants from the Knight Foundation, including work supporting the Library Box project. I'll let him talk about it. And more recently, Measure the Future. So this is a guy with all kinds of cool stuff to share with us. You are all invited to ask lots of questions at the end of this presentation. I think the intention is to have something pretty interactive here. So that we can all take advantage of how much this dude knows. So thanks, and without further ado, Jason Griffey.
Thanks. Thanks, Dave. So thanks for spending an evening with me. I appreciate that there's nothing better to do in the entirety of New York City than listen to me. Thanks so much. So when I was invited to come down and speak here at Metro, what I wanted to do was talk about some of the new research that I've been doing at the Berkman Center relating to a new kind of technology called the blockchain. I'm going to do that, but up front, we're going to do kind of two presentations. The first is going to be talking about the project that I was funded most recently by the Knight Foundation as a part of their 2014 Knight News Challenge for libraries. And I wanted to give an update just as a kind of, this is what this project is, this is what this project does, both as a note about the project itself, as it might be something that you may be interested in watching over the next 6 months, but also as a note for you as librarians. The Knight News Challenge for libraries is running another round. The call for proposals just opened and will be running until, I think, March 21st. Is that right? Do you remember the date? I think that's right.
26th?
24th? 24th, okay. We'll do it somewhere in there. So you've got just about a month to get your applications in. It's a $3 million grant pool. In the last round, when they ran the News Challenge in 2014, it was 880 some applicants. And there were 8 large grant winners and 12 smaller winners. I was one of the 8 larger grant applicants, the grant winners. We have one of the smaller ones also in the crowd. So if we have questions about either side of that coin, we have people that can answer some questions about it. But I wanted to talk about this just to give you an idea of the sort of thing that they have funded in the past for libraries, so that you have an idea of how maybe to do better pitches about the sort of thing that you might want money for. So, so my project for the Knight Foundation News Challenge for Libraries in 2014 was called Measure the Future. And if you want to follow up with us later, it's measurethefuture.net. And it was, the idea, generally speaking, was to be able to find ways of giving libraries better metrics. Prior to kind of taking this as my full-time job, I was the head of IT for an academic library in Tennessee. I was the head of IT at the University of Tennessee, Chattanooga. And we were, as the head of IT, my job was to gather all of our ACRL statistics and give them to the appropriate people for all of our digital goods. And I loathed this process. I hated it with every fiber of my being. And it wasn't because the numbers were bad or because they were hard to get. It was because they were useless to me. They were useful in showing what we have done, maybe, but they were completely useless in trying to be predictive in any way. They didn't give us any way of being, of changing our mechanisms in order to make ourselves better, right? They were dead numbers. They weren't living in any real way. So the idea for Measure the Future came about because I wanted predictive numbers. I wanted numbers that showed what was really happening in the library and how we were important to the campus. At the same time that I was kind of coming to this coming to this realization, I was doing a lot of talks at public libraries. I was working with a number of public libraries on their technology and on understanding kind of how they would kind of better move into the future. And in talking with them, I realized there were some commonalities in the sort of numbers that the public libraries were reporting and the numbers that the academic libraries were reporting. And a lot of this had to do with some of the more common numbers that libraries in general gather, like circulation, right? So all libraries gather circulation numbers in one way or another. And if how many in here are public librarians? Not that many. Okay. So in general, my experience has been that this is a very rough approximation of what circulation numbers look like in public libraries in the US. Very mild, gentle upslopes, right? And when it comes time to report these numbers to funders, you can go to your funder and go, look, it's bigger. It's a bigger number. We're doing more things. The problem is that these aren't real, and that when you really look at the numbers, it looks much more like this when you start breaking them out, right? And the things that we kind of traditionally think are the important things that libraries are working with the text are going, generally speaking, down. And we have been, over the last decade or so, fairly buoyed by the numbers in video, DVD, and VHS checkouts, right? So I think at the time I was talking to public libraries, and I realized that what was shortly going to happen was this, right? Because when streaming takes off, our numbers, our overall circulation numbers are almost certainly going to go down. And it's going to very quickly bottom out to the point where we're reporting lower numbers, and now we're going to have to go to our funders with lower numbers and say things like, I don't know. Sorry, our numbers are low. So what I wanted to do was come up with some statistics that were gatherable in an automated fashion that were really indicative of the work that people do in libraries these days. And so the pitch, the kind of elevator pitch for Measure the Future was Google Analytics for your building, right? So we use Google Analytics to measure what goes on in our digital world. We look at what people are clicking on, what they're paying attention to on our web pages, right? Which web pages they spend time on, which web pages they skip, how quickly they leave. And the idea was, like, well, okay, so if we were going to create a system that gave us this sort of data for our building, like for the physical spaces inside the library, what would that look like and how would we do it? So I have a little bit of experience because of the Library Box project, which I can talk about later if you'd like. But I have a little bit of experience with creating hardware and software projects. Library Box was funded both through a Kickstarter and then through a Knight Foundation grant. It's used in 38 countries around the world at this point, on all 7 continents. So it's a fairly successful project. And as a result, I knew a little bit about hardware and software. So I started thinking about how we could apply kind of inexpensive hardware and open source software to answer the question of how do we measure what's going on in library buildings in a responsible way that can give us numbers that matter as we move into a future where our numbers are going to stink. So the way that we decided to do this, the way that we kind of approached this problem was in 2 pieces. So the first was to build what we are calling a Scout. And a Scout, this was our initial prototype of the Scout. This was a Raspberry Pi with some storage and Wi-Fi adapters and then a Raspberry Pi camera, a little installed there, a little robot-looking thing. That actually changed a little bit, and now we're using off-the-shelf webcams. This is actually, to give you a sense of scale, that's this thing. So on the front is a webcam. In the back, in the little covered area there, is what's called the Intel Edison, which is a little tiny microcomputer. And what it's doing is it is watching a space and using computer vision to analyze how people move through that space. Okay? So it's watching the movement, and it's taking timestamps of how effectively pixels that change, right? It's like what's moving in the picture, how those moving things react in the space. So if something pauses and spends extra time in a particular place, or moves through quickly, so it's coordinates and time. And then it's relaying that information to what we call our mothership, which is a little server, which is this little thing, which is also based on an Intel Edison, a tiny microcomputer. And it's doing data visualization of that information. So in a standard setup, you might have kind of one scout that talks to a mothership, and then the mothership talks to your browser. So the mothership acts as a server, you connect to it over Wi-Fi, launch a browser, and you can see the space that the scout is watching in a kind of a data way. And of course, we're designing it so you can have multiple scouts all answering to the same mothership, all of which has a browser interface. So this next slide is a demonstration of the actual computer vision that we're doing, just to kind of show you what's happening. So this is raw footage from the camera, and then we remove the background, isolate what's moving, do a little bit of blur, and then remove the person, and what's recorded are the little blue dots there, right? So the points of movement over time, okay? That information gets saved and stored on the mothership, and then we can use that along with the keyframe to do data visualization of it, right? So we can give you basically a heat map of your space. What parts of your space are being used, what parts of your space are not being used, where do people sit, where do people not sit, which computers are the most popular. Why is it that, you have a new book display, people only stop at one side, they never go to the other side, etc. Right? We can bring those sorts of things to light through the visualization of the movement in the space. So this is an example of our kind of alpha level. This is, we're just getting this all running. You get the heat map, you get a clock that shows you effectively like when are you busy in the space, when are you not busy in the space, right? So you can see as crowds gather, as crowds leave, etc. You get overall counts of numbers of people in a space, so you can say things like our study rooms had 400 people go through there last week, right? Something like that. That is the kind of again, the visualization from the data that we're saving. So the version 1, which is what we're working on right now, we were funded in February of 2015. We will be done with our grant over the summer. Our plan is to launch then, so we still have a few months worth of work, but the features that we're working on for version 1 are what we're calling attention measurement, in the same kind of way that you get attention measurements from Google. We're going to give you that heat map that shows you what's happening in your spaces. You're going to get overall people counts, how many people went through a space over a given time slice. You get the little activity clock that gives you an idea of when a given space is getting busy and not getting busy. Because we are doing open source code, all of the data is available, right? You can get data dumps of all of the data if you want some other visualization. If you have a data wizard that you want to throw your data at and have them do something else, it's all there. We're not locking anything down or hiding anything. And because almost everyone that's working on the project is a librarian, we care a lot about privacy. I just described a situation where I'm telling you that we're going to put a bunch of cameras in your buildings. So we had to be very, very aware of the privacy implications of that. And so the first thing to note is that it's doing the computer vision analysis in literal kind of milliseconds, throwing the pictures away, and only recording those XY coordinates at a timestamp. So there's no video, no photos being stored at all in any way. As a matter of fact, we're intentionally preventing that from happening. Right? We do not want any pictures taken. So when we set this system up, there will be no storage of anything like that. All of the communication from one to the other, from the scout to the mothership, and from the mothership to your browser, all of that will be over secure channels, so people won't be able to listen in the middle and get any of that traffic. We are thinking hard about the kind of vectors of attack as to what could happen with this sort of data. So just as an example, what I mean by collapsing single stat areas. So if we imagine the kind of worst case example where a police officer comes into the warrant and says, we would like to know what X person checked out at Y time, right? We come in with a warrant. And you have this system set up, and the police realize that if they can also get, if this person was the only person in a given space and they were wandering the shelves, they could also tell they checked out a book and they also looked at these books, right? Like, because we are showing you where the busyness is, if you know there's only one person in the space, you can deduce that one person was looking at a particular place on the shelf, right? So that's kind of a worst case scenario. It may be fairly unlikely, but we're going to work to prevent it anyway. So any situation where we have single individuals in a space, we're going to collapse that into the next round of multiple people so that we don't have identifiable single visitors to prevent that kind of attack from happening as far as de-anonymizing our data. And then we're also collapsing into 15-minute recording blocks. In our standard interface, the way that we are taking kind of another level of de-identification is rather than doing 1-minute slices or 2-minute slices where maybe you could have an individual identified in the heat map, we're only doing 15 minutes, hopefully, to give us a little more variation. The phrase I tend to use is, we're not worried about people, we want the space measurement, right? What we're interested in is what's going on in the spaces. We don't really care about which individual was doing what. We just kind of want to know if the space was busy. So the idea is kind of a smart building, we're hoping. You start with one, and hopefully as you add to your network, eventually, especially in small branches, you'll be able to have an idea of kind of how people move through the space. That's going to give you the ability to do some interesting things, like A/B test spaces, right? If you have the ability to measure what people are paying attention to, you can do that for a while, and then you can change the space and compare the statistics to see whether or not your change had the effect you wanted, in the same kind of way that you A/B test digital spaces, right? You A/B test a website. You can now A/B test physical spaces with data to back up your choices. So if you want people to pay attention to a particular place in a particular shelf, you can run some experiments and see if people stop. The other thing that I'm interested in, I'm hoping that an academic library decides to do this. We have in librarianship a lot of beliefs. We have a lot of really strongly held beliefs that don't have a lot of data backing them up. One of those is that the browsing is so important, and that the ability for patrons to browse stacks is vital to the research that they do. There's not a lot of objective data for that, and I'm hoping that a system like this could bring some statistics into the measurement of that. You could, for example, put one of these in front of a range, gather statistics for a couple of weeks, see what parts of your ranges are busy and what parts are not busy, where are people stopping and browsing and where are people moving through, and then you can compare your circulation statistics with the range of books where people are stopping and browsing, and hopefully derive whether or not browsing makes a difference for circulation rates, which we believe, but we don't know. And then for management types, if you have longitudinal data about building usage, if you have a year or 2 years worth of data about building usage and about the ebbs and flows of the movement of people throughout your building, you can plan staffing predictively, right? You actually have data about when people are going to be places and when they're going to move through spaces and things like that. I'm assuming that this is going to reveal some patterns. I think that's a fair assumption. And if it does, it will help us in making sure that our librarians are where the people are going to be. And because I'm a crazy person, we haven't finished version 1 yet, but because I'm me, I've got a roadmap for version 2. So things that I think are possible with this, things that I think could come and will come once we get to that point. We're building one sensor, and the sensor is designed to give us information about movement through space using computer vision. It is by far not the only thing we can measure, right? The server that we're building, the mothership, is being built generically to handle kind of whatever data we want and to be able to import it in and overlay it with the heat map data. So we could, in theory, add other sensors, like hyperlocal location measurement. You can use small, inexpensive ultrasound sensors to tell how far away people are from things. So you could do very, very, very hyperlocal sorts of measurements about people's interaction with some of their materials. How close do they get? How far away do they get? You could also just add simple environmental sensors like humidity and temperature and light and noise, right? And if we can correlate those sorts of environmental variables with things like people moving through space, you may be able to answer questions about how to make your building more comfortable for people, right? If you notice that people leave when it gets over a certain temperature or when it gets so noisy or whatever, right? So you have some objective data to be able to plan your spaces. Something simple for version 2, like additional data views. I mean, we're giving you one view of the data, and I said, you're going to be able to dump the data and do what you want to with it. But being able to give additional views, I think, is really interesting. Do comparisons in ways that we can't in our version 1. And then data integration in other products. There are other things that do library statistics, lib analytics, and other products that a lot of libraries are participating in. That they buy from vendors. There's no particular reason our data couldn't flow into those or their data couldn't flow into ours. It's just a matter of kind of matching everything up. I think that's something that we would definitely want to look into. And then one of the things that I am most interested in long term is figuring out a way, again, kind of with privacy and security in mind, but to be able to consolidate data from multiple libraries and see if there are usage patterns that emerge from them, right? Can't really do that at an individual level. You need to get all the data into one place to do that. The most reasonable way to do that now, at least, is through some sort of cloud architecture where you throw all your stuff up to a server elsewhere and then do some analysis on it. I think that it's possible that there are some interesting things that could be noticed if we get data about building usage from multiple places in the same place. So that is Measure the Future. Again, it's measurethefuture.net, @measurefuture, measure_future if you're a Twitterer. Our plan is right now to launch in the summer of 2016. We're aiming at the ALA annual conference in June as a launch date. We have 2 library partners, a public library in Meridian Public Library in Meridian, Idaho, and we have an academic library partner in New York State. The SUNY Potsdam is our academic library partner. And we will be putting alpha hardware into those spaces hopefully next month is our goal. We're working out the bugs on our final installations now. And so we hope to be able to get things into the libraries and start testing them in March. Give us a few months to iron out some bugs, make sure they're working the way we want them to work, make sure that the librarians are happy with what they're getting, and then have it available in the summer. The plan is to have, again, this is off-the-shelf hardware. This is stuff you could get online and buy this directly from Amazon and have it in a couple of days. All of the code is going to be open. We're going to make it as easy as we can for libraries to implement this themselves. There are going to be tutorials on our website to make that easier. If you work in a library that wants more help than that, we will be happy to help you with that. But the goal is to try to get it in as many places and get people using it and gathering data and making their libraries better. So before I confuse you all with blockchain, I can take some questions about Measure the Future. What's up, Ray?
Yeah, question about when you see these cameras around, what's the idea of trying to reassure patrons that they're not being recorded?
That's actually
doing all this, but
yeah.
You see a camera.
Yeah, totally.
And lack of trust.
Yeah, I think there's two there's two possibilities. One, it's going to be an absolutely massive deal and people are going to be really angry, and two, no one's going to notice. And I don't know which it is yet.
No, they're going to know.
And well, I mean, it's yellow for a reason, right? Like it's bright yellow. I didn't do that accidentally, right? It's bright orange. So that's actually one of the main things that we want to find out from Potsdam and Meridian is we want to see how patrons react and then figure out what the appropriate messaging is for that. And that's something I think is going to have to come from the local libraries and try to work through how that comes
If
together.
there's a wild idea for up there, maybe you have mounted somewhere a monitor which just shows that black and white.
Yeah.
And that's actually what's showing, it just reassures that it's not identifiable.
Yeah, I mean, there've been a lot of ideas. We can put up signage, nobody reads signage. We can put up like web addresses for people to visit so they can see demos, nobody's gonna do that. We can put up, like, there's a lot of options, right? But I do think in the end, we're just gonna rely on our partner libraries to give us the first round, and then as we move through more and more and more places, we'll just have to refine it. It's gonna be a challenge. PR is gonna be a big challenge, so.
One more question.
Yeah, sure.
I mean, certainly, you having this moving in space, but you have stacks that are very narrow.
Sure.
You actually have a camera.
So there are going to be big challenges on how that happens, right? There are opportunities for overhead views, right? Like shooting straight down.
That's true.
And in some cases that may be the best. There are going to be places where these sorts of things are just not practical because of optics, right? Like you can't see through walls and around corners, and you're just going to have problems with that. I think that each library is going to have its own challenge when it comes to like, what do you most want to measure, and what is the appropriate place to put it to do so? And I think that answer is going to be different almost everywhere, because every library is going to have that weird corner where the stacks butt up against a wall and there's a space, and like they're just weird shapes. So.
Have you considered using other rather than visual cameras, maybe sound echo?
We've looked at IR, which has some advantages in that it doesn't need as much line of sight stuff going on. Sound is really, really hard, much harder than, I mean, you can get just noise levels, but doing any sort of echolocation, sort of actual positioning stuff is, yeah, it's beyond what we're going to do. So, what's up, Nick?
Well, for what it's worth, in almost every public library I've worked in, and that's a lot of them, they have real cameras that are watching and are recording who you are and tracking you in a much more real way than that. So it's interesting that this like brings up all of these privacy issues, but at the same time, there are security measures in place at all of your neighborhood branch libraries.
Almost all of them have them, and I from my perspective, I just want another.
I just think that'd be different than an academic institution. Feel that.
Yeah, it is. I mean, my previous one also had cameras everywhere, but yeah. All right. So, if you are interested in this and want to check in and see how we're doing, the website will have lots more information over the next couple of months. My email is there. Website where you can contact with me through contact form, and my Twitter and everything is all there. So feel free to contact me if you are interested in Measure the Future. If you want to come up and look at my toys, you can do that too in a sec. So kill that one.
I have a question. Do you think there's a risk when you make it open source? Do you think there's a risk that people? I'm just thinking of the Apple versus government argument.
Sure.
Is there a risk that someone could alter your design to make it so that you could record information?
Oh, sure. Yeah, but if what people wanted to do was record, there are easier ways to do it than like hacking my code to make it happen, right? Like you just buy an invisible little tiny pen cam and hide it in stacks, like, you know. Yes, though. I mean, that is like the upside of open is that people can modify it and make it better, and the downside of open is that people can modify it and make it worse. right? So that's the risk you run when you open up the code. But hopefully, I mean, I think in general, I think if I had to guess, and this is a wild guess just based on kind of my experience with Library Box and a couple of other open projects, in general, it only attracts attention from the people who are interested in making it work better, generally speaking. And I think in this case, it's going to be useful enough for libraries that I think libraries are going to be working at it, poking at it. Libraries that have developers are going to be poking at it, kind of making it get the data they want, right? Like whatever the visualization is that they particularly want to know about a particular space. They're going to oh, we could do that. Let's just, make the data do the thing. And then hopefully they then, give it back to the project and we can put it all together and everybody lives happily ever after in a fairy tale world with unicorns and dragons. I don't know if that'll happen, but that's what I'd like to see. So. All right. The main event. Everybody ready for we've been warmed up. Opening round fight. We're done with that. Now for the main event. Okay. All right. Stretch for this one. What, how, and why blockchain for libraries. Okay. So this is a lot of what I've been spending my time on at the Berkman Center at Harvard. And I've been having ongoing arguments online with a gentleman over in the corner there about whether or not this is actually a useful tool. So there are people who disagree with me, even in this room. So if you, if what I described seems like magic and fairy dust, it is possible it is magic and fairy dust. I don't think so. Others do. So,
there's nothing wrong with fairy dust.
there is nothing wrong with fairy dust. If you want to tweet questions at me as I talk, at Griffey is my Twitter handle. So let's talk about blockchain. How many people in here have, before you read the description of the talk, had ever heard the phrase blockchain? Okay, all right, quite a few of you. Okay, yeah, for me, that doesn't count, right? How many people in here have heard of Bitcoin? Almost everybody. Okay, so even the people that don't know blockchain know Bitcoin. That's usually the way it works. How many people in here have some Bitcoin?
Had it?
Had it? Okay, that counts too. That counts. Okay. All right, so a couple. All right. So, in very generically, we're going to talk about a little bit about how blockchain works, why it matters, why it's important. But very generically, blockchain is the technology that makes Bitcoin work, right? So, blockchain can make other things work. As a matter of principle, right now, it has only really fully been instantiated in the Bitcoin currency world. It is just within the last year or so kind of been, people have realized that you can divorce the underlying technology from that particular model and apply it to other ways of doing things, other kind of products and projects. So that's what I'm going to talk about, is how and what does it look like? What is the blockchain? Why do we care? What does it mean? And then how does it apply to some potential projects that are either libraries or library adjacent? So at its core, if you boil it down to the simplest of simple, blockchain is just a ledger. It is a list of transactions, right? There are lots of ways to instantiate that. Libraries are familiar with lists of transactions. We know how lists of transactions work. We know how to use them. We know how to keep them private. There's a lot of things that we have done that effectively boil down to lists of transactions, right? But the other way to think about a ledger, which is structured information in some sort of order, the other way to think about that is a database. They are effectively the same thing. They're both structured data you can reach in and find, then pull out. We are probably more comfortable these days calling things databases than we are calling them ledgers. Like we think of ledgers as something accountants use. We use databases, but when it comes down to the actual information contained inside, they're fairly interchangeable. So when you think of, when I say that blockchain is a ledger, it's a list of transactions. It is a special list of transactions that acts in really weird ways and does almost pseudo-magical things. But it is basically just a list of transactions. It is also basically just a database. Those are sort of the same thing. So, what sort of magical properties, right? So I said that the blockchain has kind of magical things going on with it. What kind of magical things does it have? Well, one of the things that makes blockchain a particularly interesting sort of way of storing data is that at every step, all along the way, every interaction with it, the identity of the person doing it is verifiable. Now, that doesn't mean they know it's Jason Griffey, but that every time I do something to the database, it's noted, it's me, it's provable that it's me, it's provable the time I did it, like all of that sort of information is encoded in the way the data is stored. And the other thing is you can have as many people writing as you want. You can have billions of people all writing to the database simultaneously, which is crazy town if you've ever done database management, right? Having huge numbers of hands in your database all at once is the kind of nightmare scenario for most people that have dealt with databases. But it's true. With a blockchain in general, you can have hundreds of thousands of kind of entries going on, more or less simultaneously. You can even have authors that are bad actors in the situation, right? So you can have authors that you don't trust, that you don't know, that are anonymous, and you can still let them kind of write to your database. The thing that I find most interesting about it is that among the other magical things that blockchain does is it entirely decentralizes information storage. So the way Bitcoin works, and not all blockchains work like this, and the blockchains I'm going to describe later may or may not, but I'm going to use Bitcoin as my instantiation of blockchain at this point. In the way that blockchain works, everyone that does any kind of work with the blockchain has an entire copy of everything that has ever gone on all the way back to the initial coin that was mined. So the entirety of all of the information is instantiated at every point of everyone that works on it. Okay? Now this gets big. I think the current Bitcoin blockchain is like 36 gigs or something. It's pretty big, do you know, Eric?
56.
56, okay. That's bigger than I thought at this point. I just downloaded the installer and it told me 30 something, but I figured that was out of date. So 56 gigs. So it can get very big. But everyone having a copy means that there is no way to destroy it, right? Like you can't, there's no there. It's completely decentralized and available everywhere to everyone. Robust resistance to manipulation. So again, using Bitcoin as an example, but blockchain in general, there are a series of rules that run how the ledger entries are entered and then how they are connected to each other. And the way that happens makes previous entries almost impossible to change. So once there is an entry in your data store, it's there. And bad actors can't go back and change things, right? Pretty good. And then validation for ledger entry. So every entry, we talked about verified identities, every identity being verified. Not only that, but every ledger entry, every individual entry can be verified by looking at the next block, and be kind of revisited by looking at the next block in the link in the line. And because of the way, again, the blockchain works, the magic fairy dust, anyone can look at everything in the chain anytime they want. So I can query the data anytime I want to for anything in it. Completely, verifiable. I can verify any change in the ledger. I can go back and trace individual people in the ledger. Even if they're anonymous, they're still, they have a code that I can follow. And I can independently verify that the given state of a ledger at any point. So the database, in this case, if we're talking about a database, can be at any point in its history can be verified to be correct, effectively. Just kind of magic. So this is a list. I'm going to talk about 4 of these as we go forward. First, I'm going to talk a little bit about the magic behind it and why it's called a chain, why we call it a blockchain, what is going on kind of underneath the technology that helps it get where, with all the, helps all the magic be created. So let's imagine that we have a ledger. And this is the same ledger that I showed you before, right? A little 4-line ledger right here. And each of the individual entries gets kind of written to the chain. So we give that a name. When it's written to the chain, we give it a name, block 43. The next block is going to be block 44. That's a big surprise. And one of the things that block 44 contains is a hash, kind of mathematical description of block 43. And block 43 contains block 42, and block 42 contains block 41, and block, blah, 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 right? All of that. So this is the mechanism by which the thing is all independently verifiable. It is also, there's a little more technical view of it. I'm not going to explain this because this is terrible and will make your head hurt. But it is also the reason that, again, in the Bitcoin blockchain, maybe not all blockchains, but the Bitcoin blockchain, it is the reason that it is robustly resistant to change in the past, because it is actually mathematically difficult to track back and make changes because of the way things are verified. So we're going to talk about the 4 pieces of that magic that I just described that I think are particularly important, or interesting, or thought-provoking, that might have something to do with library projects, or particularly the 3 library projects I'm going to describe in a few minutes. So the first is the distributed nature of blockchain tech, right? So there's all kinds of different networks, and if you've ever done any kind of network work, you've seen these models before. This is very straightforward. You have centralized networks, you have kind of decentralized networks, or you have kind of hubs and spokes of things, and then you have the actually truly kind of distributed network where each node is independent and traffic can flow in any way. This is the way the internet works, roughly, right? Like TCP/IP, when I say the internet, like the actual underlying structure of the internet is a distributed network. It's very robust to damage. If a particular point gets damaged, traffic routes around it. It's very robust. Centralized networks are very fragile, right? If that center point goes out, suddenly everyone loses everything. Decentralized ones are less fragile, but still, if one of the decentralized nodes goes out, all of the surrounding nodes lose their connectivity. So in Bitcoin blockchain terms, the distributed network is what we're after. Robust, resistant to change. Every node is its own, again, copy of the information. So it's kind of disruptible in the same kind of way that that a lot of information sources and networks are these days. If you, instead of talking about it at a network level, if you talk about it in a kind of an information flow level, one of the reasons that blockchain is particularly interesting at Berkman and in kind of the internet world at this point is that a lot of our information flows, the social flows of the things that we create are much more centralized than they were at one point, right? Facebook, Twitter, Instagram, those sorts of things. All of our communications are centralized around those single services, and in, again, a service model that was fully distributed, you avoid that sort of data lock-in and things like that. So there's a lot of work going on that has to do with using blockchain to decentralize services, not just kind of network level, but actually the service level of things. So the other thing that I think is interesting about blockchain is its immutability, the resistance to change. So I'm going to get a tiny bit technical. So the way that each of the individual blocks, you see the kind of you've got the hashes, the previous hashes from the previous blocks. A hash is just a mathematical function, right? It's a way of doing a lot of math. It's a fancy math problem. And the way for the Bitcoin blockchain, not all blockchains, I'm going to say that a lot, but the Bitcoin blockchain, the way that a block gets kind of gets officially made a part of the chain is through what's called mining. And this has to do with very fancy math and lots of great big heavy computers that burn more coal than almost anything else on the planet at this point, I think. There's a lot of electricity being eaten by these things at this point. But it does a lot of math, and when a particular solution is solved, that indicates that the block can be added to, that particular block can be added to the chain. And every block, in order to change it, you have to redo the entirety of the math, right? You have to redo all of the math that was done in order to solidify it in its place. And if you wanted to change a chain behind the block that you've got, you'd have to do the math on it, and then the math on the one before it, and then the one before it, and the one before it. And eventually, that just becomes kind of more math than a computer can do. Like it is just technically something that would be cryptographically impossible. So the fancy math is what kind of locks the blockchain into where it is and makes it very resistant to change. So verifiability is the third of the things that I think are interesting about the blockchain. And verifiability just has to do with whether or not you know who is putting entries in, and then kind of what happens to their entries. So this uses fairly straightforward cryptographic signing, very similar to kind of secure email or secure messaging apps where there's a public key and a private key. You have a private key, you use your public key to sign your entry into the blockchain, therefore it is verifiable that it is you, mathematically verifiable that it is you, and anyone can browse that and go, oh yeah, that line, second line, that was Jason. Why? Because his key is associated with that particular entry. I can prove that that was him. So the verifiability of every entry, I think, is important, and will come up in one of the things I'm going to suggest might be useful for libraries in a little bit. And then the last thing that I think is really interesting, and this is the part where a lot of people disagree in the blockchain world, is consensus. And I've described this magical database-y thing, and I've told you that anyone can write to it, and that you have to solve some fancy math in order to get in order to add add new entries. And that's all true. But it is entirely possible that you can have conflicting entries, right? It is possible that two people could simultaneously solve a problem, and then you end up with conflict, right? You have two different entries that should be there. In the same way that you can have failure at two disagreeing entries in a database. You have two people fighting over it. That's why databases operate in lock states and everything like like that, right? So the blockchain uses a form of consensus in order to determine what choices to make when there is a conflict in the chain. Okay? Those are determined beforehand. When you write the software, you basically put in an algorithm that makes the decision for you, so that it's an automated consensus. This is an algorithmic consensus. Mathematical, it's something that is built into the system. It doesn't involve people most of the time. And we operate kind of in the world, kind of in our social world, we operate via consensus in a lot of different ways. It's just that we don't often think about it algorithmically. Things like the legal system is more or less a consensus-based system. Things like money and inflation are a form of consensus, and the stock market is a form of kind of consensus operations. In the blockchain world, one of the ways of doing consensus work is called proof of work, and this has to do with the way that things are added to the chain, and Bitcoin particularly uses what's called basically the longest branch rule. So if you have two entries that happen simultaneously, right? So you have two conflicting entries in your chain, the system waits, and it waits for the next thing to be mined. And then when the next thing is mined, whichever chain it gets added to becomes the official chain, and the other one kind of fritters away, becomes an orphan. So you end up with one continuous chain, and that's the way that Bitcoin solves this kind of consensus problem. There are other ways of solving the consensus problem, including ways that I think are kind of only theoretical at this point and aren't instantiated anywhere. But the other one that gets often talked about in the blockchain world is what's called proof of stake. And proof of stake says that whoever has the most stake, whoever has the largest kind of stake in the system, is the one that makes the decision about which chain gets chosen. So if two people attempt to add to the chain at the same time, the system goes, okay, well, Jason has done this more than Nate has. So if I have to make a choice, I'm going to go with Jason. That's the way proof of stake more or less works.
Hey, wait.
I know, it's not fair. It's not fair. Consensus algorithms and consensus, the study, kind of the mathematical study of consensus is actually a fairly young part of math. It is really something people are working hard on, and I feel fairly confident that there will be others. The good thing about the consensus part of the blockchain is that you can take one out and put another one in, and it's still blockchain, right? Like the only kind of real key is you need some way to break ties. As long as you have a way, you're fine. But these are the two big ones: proof of work and proof of stake.
Sorry, when you say break the ties, do you
Yeah.
mean
Simultaneous entries.
Oh,
Yeah.
okay.
So if there's two simultaneous entries, you have to choose which one to choose,
okay.
right? That's all I need. And the two ways that we currently have to do it are more or less proof of work and proof of stake. I think there are others, but especially in private blockchains, there are other ways you can make it work. You can actually do voting. You can literally vote on which one you wanted if you wanted in a private blockchain. So the four things I think are interesting. Oh, sorry. Let's go back. Distributing, immutable, verifiable, and consensus. Those are the four things that I think are interesting about blockchain. So what can you do with that? Like what's being built? What can you do with both the technology of the blockchain in other areas? And there's a huge amount of work being done. Bitcoin is the big one, and there are all sorts of coins. There's Dogecoin and altcoin and Litecoin, and there's all sorts of coins. Currency is the big kind of thing that people latched on too quickly because using a blockchain for currency turns out to be a really good idea. There's a lot of other options, though. There's a lot of other options on how you can use blockchain in a system. And there's a couple of good reasons to do that I'm going to talk about in a second, but I just wanted to give you an idea of the sorts of things people are doing. So Namecoin is a distributed blockchain-driven DNS system. So it's a domain name system for the internet, except driven through blockchain. Bitmessage and Twister are both Twitter clones, effectively, decentralized Twitter. So it's Twitter, except there's no company that owns it, right? It's all out at the edges. Eris and Ethereum, Eris Industries and Ethereum are both companies that are doing work in what's called smart contracts. I want to talk about that in a second, because I think that's a pretty cool area. Stampery is literally an online notary. It's like, we will officially notarize that you gave us this particular file at this particular time, and then we will write that to the blockchain where it will be forever, saved. So it's proof of effectively provenance, right? Like trunk. Deckbound is a collectible card game based on the blockchain, which I thought was fantastic in a weird kind of way. Etheria is a Minecraft clone based on blockchain. So it's Minecraft, except there's no central server. It's all driven out to the clients, and it uses blockchain tech to sync everything up. Right? I don't remember Ribbit. You'll have to look that one up. Mycelia is one of my favorites. Does anybody know the artist, the musician Imogen Heap? Imogen Heap. So Imogen is actually working on the system called Mycelia. It doesn't have a website yet, but if you Google Imogen Heap Mycelia, you'll get to her blog entry on it. And basically, what she's trying to do is to build a market for music on the blockchain. So an open, decentralized market where people can buy and share and trade music on the blockchain. I'm going to skip a few of these. Open Bazaar is eBay on the blockchain, basically. Let's see, I don't remember either of those last two. The winner for name, just purely the name, the winner is Token. Anybody want to guess what Token is? It's a fantastic pun. You know? It's financial services for legalized marijuana. It's fine. All right. So the two phrases that get thrown around a lot in the Bitcoin, in the blockchain world, and if you wanted some Google, some Google tools, these are the two phrases that you want to search for. The first is distributed autonomous organization. Okay. What in the world does that mean? It sounds like something in a cyberpunk novel that's going to eat us all, right? A distributed autonomous organization is basically that. It is an organization where the entirety of the code of the behavior of the organization is written into the blockchain. Written into a blockchain, which means that it operates entirely decentralized from any owner. Okay? So here is an example of the sort of thing that you can do with a distributed autonomous organization. This is one example among lots of others. So an artist, a friend of mine worked with an artist to build a sculpture that had in it, as a part of its kind of physicalness, a computer, and that computer had in it code that was running on the blockchain that accepted currency on its behalf. So you could send Bitcoin to the sculpture, right? So you could walk over to the sculpture and take your phone and send it some Bitcoin. The sculpture as a thing, as an organization, accepted the Bitcoin. When it got enough money to build a replica of itself, it contacted artists and offered them contracts to do so. And then when an artist accepted a contract to build a copy of itself, it paid the artist, and then the artist built another copy of it, and then it did it again, right? So this is a kind of an autonomous agent that is able to legally interact with the human world through smart contracts and accept payment, and very strange concept. Smart contracts are the other thing I wanted to talk about. So one of the things that people are most excited about with blockchain tech is that one of the things that it decentralizes is the concept of notaries and authority, right? So right now, if you want to, if I wanted to go to Nate and sell him something and write a contract up for it, I would consult an attorney, and the attorney would suggest ways that the contract would work, and then I would sign it, and he would sign it, and we would file it somewhere. A smart contract kind of does away with all of the legal system, because since blockchain can verify that I agreed to something and verify that Nate agreed to something, and that is immutable and unchangeable, and we can always verify it, and the text of the contract itself can be saved in an immutable, unchangeable form, you can do peer-to-peer contracts without kind of outside legal kind of help or arrangement. So smart contracts is something people are really interested in. There are some big players that are playing kind of in this space. Sony just announced a couple of days ago, actually, this is February 22nd, that they are developing an education and testing platform based on blockchain. And IBM is looking at doing kind of blockchain as a service, providing blockchain services to businesses that want to build on top of it. So that it's not just kind of crypto anarchist Bitcoin weirdos, although it is largely crypto anarchist Bitcoin weirdos. But there are big companies that are getting into this game because they think it's got a lot of potential. So speaking of potential, let's talk about possibilities for libraries. So there are kind of three things that I dreamt up that might work that combine the blockchain and library interests. And they go from very simple to much more complicated. So I'll start with a simple one. And the simple one is a word that I already used, and that's provenance. Libraries don't often worry that much about provenance, but it's something that comes up in the museum world all the time, and it certainly lives in the archives world all the time, right? So library and library adjacency, provenance is a big deal, and tracking it can sometimes be really difficult. Tracking provenance becomes a lot easier if the metadata that reflects the chain of ownership or data about the object, during its ownership, is written to an immutable, unchangeable, publicly verifiable source, like blockchain. And of course, it doesn't have to just be physical items that have provenance, right? Digital items can have provenance as well. So if you think about those of you that are in academic libraries, how many of your academic libraries are running a research, my brain just stopped. A repository, thank you. I'm like, repository. How many of you are running a repository? Right? So your repository probably has like data about the things that people put into it, right? But if your repository goes away, then the data goes away, right? Writing the provenance of digital objects into a distributed database that lives in everywhere, probably not a terrible thing to be doing. It certainly is more secure than a server that lives in your closet or somewhere in the cloud, which is just other people's computers. So provenance is something that, again, libraries care about, especially in the instances of things like repositories, but museums and archives care lots about, and being able to do that work in an immutable way is a big deal. The second thing that I think is interesting, maybe, although a lot of people have argued with me about this, Eric, is whether or not it might be interesting to do some form of bibliographic metadata on the blockchain, using a blockchain-like system. So what I have in mind is effectively a decentralized OCLC, right? I mean, OCLC has everything and they're in one place. But if everywhere could have everything, I think we live in a better world. So, it's a bias. So if we had things like, if we build a chain, if we imagine a chain, and we have a blockchain system and we're writing book metadata to it, so we have, book 1, and then book 2, we have a mark and RDF, whatever else we want to throw in there. And then somewhere along the chain, we want to edit, we want to update a piece of metadata earlier. We can just write that directly there. We can write that to the chain. We can reference the previous one because, well, we have mathematical references for everything all along, up and down. We can continue writing metadata. And, in theory, it could look something like this, where we have metadata saved in the blockchain, in a blockchain here, and then somebody notices that my book is not actually a sound recording. This is actually the OCLC record, so thanks, OCLC. So it's not actually a sound recording, and I want to change that, and I want to dump the subfield H. I want to get rid of the subfield H in the 245, so I just write that to an update on the metadata, and go along adding other stuff. So let's say I have all this data, traveling down the chain. People can update as they will. If I want to pull that data out and put it into a display system, I can read it in a couple of different ways. I can choose the level at which I wanted to display the records about the books. And one way to do that would be to read to the most current chain, right? So I could look at whatever the most current entry is and be like, okay, so that's the state of my bibliographic entry. That 245 should replace the 245 that's in the one previously, so I'll build that right programmatically as I go. And I can do that. We can make as many changes as we want and update them on the fly in our display system as we pull things out. The other choice would be, instead of using the most recent, I could maybe prioritize certain writers, right? Because we have authorship at every level here. I could choose to only display things that the Library of Congress wrote. Or I could choose to prioritize my own local cataloging over the things that the Library of Congress wrote. And I can do that by literally just changing the key that I look at as I fly down this, reading it out. The cool part, I think, right, is that it would be completely distributed and everyone would have a copy of it and it wouldn't be beholden to any particular single actor, and there would be universal agreement, and when someone made a change, it would be automatically propagated everywhere, and there would be automated reconciliation of problems, and everyone could always edit it all at the same time instead of being locked out of a connection record. And so I think there's some good things here. I think there's some possibilities. So there's problems too. There's problems. One of the big problems is that bibliographic information is actually really freaking big, and there's a whole lot of it. OCLC has lots and lots and lots and lots and lots and lots and lots of records. But text itself is not that big. So I don't know what this would look like. Would it be bigger than the blockchain, like the Bitcoin blockchain? I'm not sure it would. What do you think? Do you think it would be, if we blockchained all of OCLC, would it be bigger than the number of Bitcoin transactions that have happened? I actually don't know. I don't even know how to get with an order of magnitude being right, but it's possible.
Yeah.
So, but I think there's some potential for something interesting to come out of a system that looks like this. And then the thing that I think is really interesting is the potential to build a system based on blockchain tech that may give us back a right that we don't have now. And that would be for sale rights, right? So the reason the libraries exist is that in the US we have a first sale right to physical items. If we have something physically in our possession, we are legally allowed to resell it, give it away, lend it, burn it, whatever we want to do to it, right? We can do whatever we want. You don't have that right with digital goods. Digital goods are typically licensed to you. But I think one of the reasons, right, that digital things are licensed and not owned is that there is no proof of ownership of them. They are infinitely copyable, right? One of the common complaints from publishers about ebooks is that, well, if we don't give it to you locked with DRM, then everybody will have it and you can just give it away to anybody you want. Well, so what if we had a system that was something like the blockchain, something very, very like the blockchain, where you had a user, and the user wanted a copy of a book, and the system locked that book with his public key, right? So we have cryptographic proof, mathematical proof that user 1 owns book 1, right? And that's provable because we have written it to, again, a database that is unchangeable and time-stamped and cryptographically secured. So if we get to the point where we have this system, user 1, book 1, we can prove to anyone that asks that user 1 owns book 1. And if user 1 wants to give book 1 to user 2, he can actually literally take away his own ownership and give ownership to user 2 through a blockchain transaction, in the same way that I can give you Bitcoin, right? So I can, again, verifiably, cryptographically, make myself unable to access the book and give it to Nate and make him able to access it and prove that he owns it, right? And we can do that over and over and over. That looks a lot like lending to me. And because we have proof of this, because we have again, cryptographic, mathematically functional proof of every step all the way along, we can prove to a publisher that user 1 can no longer access this book. Even if he happens to keep the bits, he can't unlock it because the blockchain tells him he doesn't own it anymore. Now, the traditional model for this system might be something like publisher and bookseller sell to a library, right? The library checks out the book using this cryptographic system to the user. That's again, fairly common. It would very quickly devolve into the publishers and the booksellers, right, trying to get at them directly, because that's the way they work, because we've seen this with Amazon and we know how this game plays. The difference with the system that I'm describing is nobody has any control. It's all decentralized. So once a book is in the system, nobody can stop it. Once it's controlled by this new kind of digital tool, everyone becomes an even player. The library, the bookseller, the publisher, and the users are all on an even playing field. They're all peers in the network. There's no nodes and owners and servers. And the DRM involved is cryptographic signing keys and public key encryption, which is a well-known and well-backed and easily understood piece of tech. The blockchain records all of the sharing and everything. And I think we get lending with digital objects. Now, the question is whether provable scarcity equals first sale rights. And I don't know if that's true. That's a hypothesis, right? First sale is something that would have to be litigated. I have no idea whether this is legal. It almost certainly is not legal. That hasn't really stopped people from building things before, so I'm okay with that. So I don't know if this is true. I don't know if provable scarcity of digital objects is the same as having a first sale right to them. That is an open legal question. I don't know that. However, I do know that theoretically having a distributed and open market might be a good thing for the publishers at this point because Amazon's eating their lunch. And having the ability to sell directly to people rather than going through Amazon might make them really happy. I also know that because we can layer the whole thing on top of blockchain, we could actually build into this system microtransactions so that the users could pay for the books directly in the system. All of this could be done through effectively Bitcoin, right? You could use a virtual currency to drive the entire thing. And the transactions involved also wouldn't be locked to booksellers and publishers, right? So if user one wanted to give his book to user two, he could do that. But if user one wanted to sell his book to user two, he could do that too. It would be a completely open market for that sort of thing. One other thing it gives publishers is that because, again, we're running this on a blockchain, all of the transaction data is all open. The publishers would know what the books are that moved around the most because they could just look and see if their books moved around the most, right? This is all open data. They could see it, which is, again, more than they get now from existing booksellers. They don't get a whole lot of data about that sort of thing from Amazon directly. And then it maintains some pseudonymity for readers. It's not anonymity really, but you could organize this in a way that a reader maintains some pseudonymity. Again, because we're using microtransactions via a digital currency, it would be possible to get into this system without having a U.S. credit card and Amazon. The magical key to Amazon, and readers could no longer give their purchasing information away to, everyone, because you couldn't necessarily prove it was them. So, this is very new. It's so new that this is literally the first time I've ever said it out loud in front of a crowd. So, I am in the middle of writing a white paper about this, trying to sort out what the pain points are, figure out how one would build something like this. This may be the next thing I try to build. I'm not sure. I'm gonna see kind of where the pain points are. But I think that there's some potential here to do some really interesting things in a market for media, specifically books, but any sort of media can be thrown into this. That's driven in this way. And with that, I'm going to say thanks. And I'm going to ask if you have questions. Yes, ma'am.
Wouldn't the market for the publisher or producer be saturated really quickly and they'd have nothing to sell anymore? Because everybody else is selling it to each other.
Oh, well, I mean, is the market for new books like eliminated by the market for used books?
I think this sounds like it'd be really easy to find a copy when you want it.
It would.
And nobody would lose it at the beach or.
Yeah, they would.
That it would just be too perfect and
Yeah.
that you would only need so many books to
Did you
saturate.
just say that in a room full of librarians? You can only need so many books?
No, so many copies,
I know, okay.
sale points or
I know,
whatever
I know,
of
I know.
individual
Yeah, it's true. Totally.
products,
Yep.
Then would it have to dovetail on like BitTorrenting, where you only get parts at a time?
Oh, that's interesting. The atomic units could be different.
Yeah, like, because if you think about
Yeah.
torrenting, I mean, there's thousands, millions of players, but
Yeah.
you still can't find everything.
No. Well,
I'm not saying
you
that.
can't find
I
in this particular instance, does it have the potential to be very disruptive for publishers? Yes. I find it hard to worry that much about that.
One approach is the Wu-Tang approach, right? If you
Yes.
just release one.
That's right. Totally.
Secondary market will decide the price from there.
Yeah, that would become the Stephen King model in this. I think. Yeah, that would
What's
become
interesting is that
yeah.
with the public key and the blockchain, you're making that digital copy of that book just the one copy. You can't copy it.
Yeah. Well, you can't. No one can force you to. You would have to do it.
Yeah.
You would have to do it willingly, right? Like you'd have to give it away or sell
Right,
it.
exactly. Lose your ownership.
Yeah. You'd have to voluntarily lose your ownership. Yeah.
Right.
Yes, sir.
How does this work with another movement right now, open access, right?
Yeah.
We're not trying to, we're interested in the provenance of metadata.
Yeah.
And we're interested in the pseudonymity of our users, so we can track analytics and prove to our boards that we're measuring things just like you're trying to do spatially, but with data.
Yeah.
How does that work together?
Yeah, so, I mean, you'd still get provenance, right? Because that's the way blockchain works. You could write provenance data into the metadata without any problem, I think. And you would get the transfer information, so you'd see how it bounces from researcher to researcher. You wouldn't know who the researchers were, and that's okay. You'd still see how the data moved around. I mean, I think you could dump Sci-Hub into this tomorrow, and it would work out great for everyone. Not that Sci-Hub is open access, I know. But yeah, I mean, I think it would dovetail well with open access. You throw as many copies as you would like into the system and let people share them, and then mine the data out afterwards. I think it would work fine. Yeah.
I just, back to the question earlier, I feel like any of these projects, if they were really to flourish, you'd have to have a dedicated computer for them.
That's possible. That's possible. I mean, although when you say a dedicated computer, it might.
A computer in your house.
It might be a computer that looks like this.
Right, but still, I mean, I'm thinking about just cost effectiveness. Like,
Sure.
how are you managing these? And then you're constantly updating. What if you get everybody on the planet wanting one particular,
Yeah.
blockchain, and then you got to get everybody on the planet's information, even if it's tiny smalls. I get it, but
Yeah. I mean, scale is a problem for everything, right?
Yeah.
Although, by and large, I tend to trust that, in general, scale is fairly manageable in computers via the growth of processors and the increasing cheapness of them, right? So like instantiating this today would be, I mean, not remarkably, but like somewhat expensive on the processing side. You'd have to have a computer probably. But in 2 years, you can probably run exactly the same thing on your phone, and 2 years from that, you'll be able to run it on your e-reader, and then 2 years from that, you'll be able to run it on your serial box, right? Like, it just gets cheaper to do the same work over time. So I think ultimately, it would be fine, even if like right now, it's not. It's possible. It may not be. There may be, Bitcoin is intentionally designed so that the difficulty of the math ramps over time. So it actually gets like technically more difficult to do over time. And this has led to an arms race and hardware and all sorts of crazy things. But it doesn't have to be designed like that. It's something like this I don't think would be. It would be designed for much lower processing power. So.
When you're saying that's actually in order to operate this, you have to have the entire blockchain on your computer.
Yes.
So
Yeah.
it just seems conceivable it gets so big that your computer can't handle it.
I mean, the phone in my pocket could hold the entirety of the Bitcoin blockchain. Like I'm not too worried about storage. Storage is cheap and ever increasing, and theoretically it could. I mean, one of the interesting things is that the system doesn't actually have to hold all of the content. It just has to hold pointers to the content, right?
Yeah.
So you could distribute all of the content via BitTorrent if you wanted, and distribute that among everybody, and no one place has to have it, but only the data is in the chain. And there's all sorts of things you can play with as far as the storage goes.
But if your system, if you're just storing pointers, aren't you moving the security question of the provenance just one step outside of the blockchain?
I don't think so. I mean, as long as the hashes match, you're fine, right? Like as long as you can prove.
Okay, so as long as you're talking digital apps.
Yeah. I'm talking digital applications for the Because yes, it gets weirder with physical things.
Yeah, well, you said you start with provenance.
Yes, totally.
I got a little bit.
Yeah. No. You're right. I mean, physical objects, that would not be.
Okay.
That would not. All right. Well, why don't we have another drink and hang out for a couple of minutes and talk?
Please.
So, thanks guys for listening. Again, this is me. I'm happy to answer emails, talk, chat, whatever. These are really rough ideas.